Charge is the name given to the unique electromagnetic property possessed by electrons and protons. It cannot be found anywhere else. The properties of electrons and protons are very similar but have some obvious differences. By definition, electrons are said to have a negative charge and protons a positive charge. The symbol associated with charge is the letter uppercase Q, and its unit is the coulomb, abbreviated to the letter uppercase C. As the amount of charge carried by one proton or one electron is very small, the unit of charge is always considered in multiples of electrons or protons. 1 coulomb of charge is the charge possessed by 6.25 times 10 to the power 18 electrons or protons. A charged subatomic particle possesses an electrical field similar in nature to the magnetic field around a magnet. As a result of this field, if two charged particles are brought together, a force will exist between them. This force is measured in volts. Particles with unlike charges, i.e. a positively charged atom and a negatively charged electron, will experience a force of attraction, while those particles with like charges, for instance 2 electrons, will repel each other. The effect is very similar to that exhibited between the poles of a magnet. The following example is in the accompanying workbook, Basic Units, Charge and Current. Part A is to find the number of electrons in 3 coulombs of charge. We know that 1 coulomb of charge is equal to 6.25 times 10 to the power 18 electrons. So, if we have 3 coulombs, the result will be 3 times that amount. So, 3 coulombs equals 3 times 6.25 times 10 to the power 18 electrons, which equals 18.8 times 10 to the power 18 electrons. Part B is to determine the number of coulombs of charge for a given number of electrons. By inspection, we can see we do not have enough electrons for even 1 coulomb of charge. So the question really becomes, how much of a coulomb do we have? This can be determined by dividing the given number of electrons by the number required for a coulomb. So, number of coulombs equals number of electrons divided by 6.25 times 10 to the power 18, which equals 9.38 times 10 to the power 16 divided by 6.25 times 10 to the power 18. Therefore, number of coulombs equals 15.0 times 10 to the power minus 3, or 15 millicoulombs.